Hello everyone, welcome back to my YouTube channel. Today we're exploring Ganymede, Jupiter's largest moon and the biggest moon in our solar system. In mythology, Ganymede was a beautiful young boy who carried to Olympus by Zeus, the Greek equivalent of the Roman god Jupiter disguised as an eagle. This was the description given on nasascience.gov. Ganymede became the cupbearer of the Olympian gods, which is an appropriate name because this moon is full of water and being the planet that it orbits, the king of the planets. Today we're going to explore its structure of this large moon and dive into some fascinating facts about this colossal sized rocky ice body. Ganymede is not just any moon. It's the largest moon in our solar system, even bigger than the planet Mercury and actually quite comparable to size to Mars. With a diameter of about 5,268 kilometers, it holds many secrets waiting to be uncovered. A noticeable feature of Ganymede is its smooth surface, which is a mix of two types of terrain: highly cratered dark regions and lighter regions marked with an extensive array of grooves and ridges. These lighter regions are believed to be somewhat younger and more geologically active, but separate the geology of the moon into two different distinct categories. Let's mention something truly unique to Ganymede. It's the only moon known to have its own magnetic field, and this is a big deal. This discovery was made by the Galileo spacecraft in the 1990s and has intrigued scientists ever since then. Its magnetic field is generated by its particularly liquid iron-nickel core, similar to that of Earth's magnetic field. This magnetic field creates auroras around the moon's poles regions, which have been observed by the Hubble Space Telescope, and they're pretty awesome to witness. The interaction between Ganymede's magnetic field and Jupiter's powerful magnetosphere causes these beautiful auroras. By studying the way these auroras move, scientists have also gathered evidence suggesting that Ganymede has a subsurface ocean. But unlike Europa's, it could be layered into several different sections of subsurface oceans, meaning that there could be solid layers and oceans underneath those layers. And in fact, Ganymede may have a salty ocean beneath its icy crust, which could contain more water than all of Earth's oceans combined. This subsurface ocean makes Ganymede a prime candidate in the search for extraterrestrial life. But unlike Europa, Ganymede is also outside the bounds of the deadly radiation belts that Jupiter has, meaning that radiation levels would be significantly lower with this moon's surface. The ocean is believed to lie about 150 kilometers below the surface, sandwiched between different layers of ice. The possibility of hydrothermal activity on the ocean floor, similar to what we see in Earth's oceans, adds to the excitement about potential habitability. Ganymede's diverse surface also features impact craters, some of which have bright rays extending from them, indicating relatively young impacts. There are also features called palimpsests, which are believed to be the remnants of ancient impact craters that have been flattened over time. Ganymede's geological activity is another fascinating aspect, with the moon's grooved terrain suggesting tectonic processes, where the icy crust is thought to have been stretched, causing fault lines and ridges. These grooves and ridges, some extending for thousands of kilometers, are the testament to the dynamic history of Ganymede's surface. The geological activity hints at the internal heat that may help maintain the subsurface ocean in a liquid state. Ganymede has been explored by several missions, including Galileo's spacecraft, and more recently, the Juno mission. Future missions, like the Europa Space Agency's JUICE mission, aim to study Ganymede in greater detail to uncover more about its magnetic field, subsurface ocean, and potential habitability. The JUICE mission, set to launch in the 2020s, will conduct detailed observations of Ganymede, as well as Europa and Callisto. To help us understand more about these icy moons and their potential to support life, there's a long journey ahead, as these moons are very far away from Earth, but the destination is worth it. So I hope now you have a better and greater understanding of the general knowledge of this moon. To recap, it is the largest moon in our solar system, with its unique magnetic field, potential subsurface ocean, and dynamic geological features. It's a very special moon and intriguing in every way possible when you're into this kind of stuff like me, and assuming that you're watching, you as well. I hope you enjoyed this video. Give it a thumbs up and share it with your friends. Let me know in the comments what other celestial bodies you'd like to learn about. And thank you for watching, and I'll see you all in the next video. Have a good rest of your day.